All right, problem number 5. This is where we start computing the binomial probabilities. So we're given that there are n trials. The probability of success is 75 or 0.75, and we want the number of success to be 9. So I'm going to show you about 3 or 4 different methods. Mainly, I would suggest you use the table and or StatCrunch. So I'm going to show you the table. There's 2 tables. I'll pass these out in class, and I'll try to add them to Blackboard. So with the table at the top, they give you different percentages. So you would need to find the percentage that we're dealing with, probability of success, that's P. So we have 75. Then you need to find the number of trials. So on the left side, you have different numbers of n for the number of trials. So this first page goes to 7. So if I flip this over, we have 8, 9, and then 10. Okay, so we want 10 to be our number of trials. Our probability of success is going to be 75. So this column, I'm going to come down until I meet, I can't get it all up there. I'm going to come down until I meet 9 success. So this row, 9 success, I'm going to go all the way across until I meet that 0.75. And so this table is giving me 4 decimal places, 0.1877. So with binomial, with 10 trials, 0.75 success, and we want 9 successes, this is 0.1877. This is from the table. So all you got to do is find the probability, find the number of trials, find the success, and this is what you get. Now there's 2 tables. There's a PDF, and I'm just going to tell you, refer the D to be discrete. It means density, but discrete. Remember, discrete, we're dealing with whole numbers. Okay, so there's a discrete table. There's also a cumulative table. Cumulative table has added up the probability. So it's everything 0 up to that point. So I want to show you how to use the cumulative table as well. Sometimes this table will be better, but you can use either. But if you want to use the cumulative table, we would do the same thing. We're going to find the right number of trials, which is 10. Sorry, it's kind of hard to see. It's kind of small. But this table doesn't have the 75%, so I wouldn't be able to use this table. But if we were, we would go to 9 successes, and 9 is adding up everything from 9 and below. You find that probability, and on the cumulative table, I'm going to kind of show you how to do that. Cumulative, which is the CDF, cumulative distribution function, cumulative. Cumulative table, if you found 9, this is what the table is showing you. The table is showing you the probability of 0 plus 1 plus the probability of 2 all the way up to 9. Okay, so it's already added them up together. So when you see 9, it's 0 through 9. If you want to use the cumulative table to find that probability, if you had the correct probability of success, you would use the table and find the probability of 9, and you would subtract the probability of 8 or less. So it's, x less than or equal to 8. So what this would do, it would take 0 through 9, it would subtract 0 through 8, and it would leave you with just a probability of 9. So you'll see that later on, but I just want to mention it now. You should get the same thing that we have here. Okay. So this is going to be the preferred method. Either you can use this table, or the next method I would recommend is StatCrunch. Okay. So if I do get more help and I do StatCrunch, we get the StatCrunch calculator. We're going to go to Stat. We're going to go to Calculators, Binomial. So down here we will put our information in. So we have 10 trials. We can leave that the same. P is 0.75. So I'm going to come here and change this to 0.75. And then we want to find equal to 9. So in this box, I'm going to change this to equal to, and then change 5 to 9, and then hit enter, and it computes, and you can see those first 4 decimal places, 0.1877. Okay, so you can get that same thing with StatCrunch. With your calculator, if I turn it on, if we go to Math, and we're going to arrow over to Probability, if we arrow down, maybe it's not Math, second bars for distribution, that's what it is, second bars for distributions. So not Math, second, and then bars, that gives you distributions. If we scroll down, we have different ones. You see you have a binomial PDF, you have a binomial CDF. So I can show you that binomial PDF for discrete. So discrete will take these input: number of trials, I'm going to put 10, probability of success 0.75, and the X value, how many success do you want? 9. When I hit paste, it puts it up in this format: trials, success, how many successes. And I hit enter to compute, 0.1877. Now with the cumulative distribution, if I do second bars, go down to distribution, I'm going to go CDF this time. So I'm going to do 10.75, 9. Now what we really want is 9, but this is going to do 9 and add everything up. Okay. So if I do this, it shows me this number. So that's 0 through 9. Now I want to subtract from that. I'm going to do second bars. I'm going to do the CDF again. I'm going to subtract 0 through 8. So I'm going to put an 8 here now. So what the calculator is saying, I'm going to take this probability, which is 0 through 9, I'm going to subtract 0 through 8 with the C, cumulative. And if I hit enter, it's going to subtract those two, and it shows me 0.1877. So if you use the table and you had the probability, you can just subtract the two. Of course, in class we can practice a little bit more. My preferred method for you to use is the table, or use StatCrunch. It's already here in the system. I will also show you the formula. So the textbook gives you a formula, but you don't have to use the formula. The formula is NCX. So we have number of trials, how many success we want, times the probability of success raised to the X power, times the probability of failure, which is 1 minus P, raised to the N minus X power. So what this would mean is I would say 10, choose 9. So there's a bunch of ways that can happen. Our probability of success is 0.75. We're going to do it to the 9th power. My probability of failure would be 1 minus 0.75, which would be 0.25. And I would raise that to the 10 minus 9, which is going to be equal to 1. So when you add up these two exponents, it should equal your total number of trials, which is 10. You got 9 success and 1 failure. That gives you all 10. So I'm going to put this part in the calculator just to show you that this will compute this as well, but you don't have to do the formula. I just want to show it to you at least one time, and then from here on out we'll just focus on reading the table and using the applet that we have here in the program. So in the calculator, I'm going to do the combination first. I'm going to enter 10, and then I have to go to Math. I'm going to go over to Probability, and I'm going to choose 3 for NCR. So 10 NCR, and we're going to get 9 success. We're going to multiply this by 0.75. We're going to raise that to the 9th power. And then we're going to multiply that by 0.25, the failure rate. We're going to raise that to the 1st power, which you don't really have to raise it to 1. It's understood, but if you had to raise it to some number other than 1, you want to put that there. All right, so this is the probability distribution formula. And you see we get 0.1877. So it says round to 4 decimal places, so we just get 0.1877, and we are done.